Okay guys, welcome. This is the first in a series of programmable logic controller lessons that I'm going to be doing and uploading to YouTube. This is now the third time I've recorded this. The first two times the sound was off, so I've spent all morning trying to get this video working. So please read it, please listen to it, enjoy and take something from it. Right, so the assessment criteria is all about assessment criteria 1, learn outcome 1, learn outcome 2 from assessment 1. Unit 15, which essentially talks about how the hardware is interfaced and built and maintained and things in a PLC. So essentially there are three types of PLCs, small, medium and large. They all have their own uses. We'll look at some typical technical specifications, and I'll put some technical terms on the end of this lesson for you guys to have a look at yourself. What I would say is I'm not going to go through the technical terms on video simply because I'd be reading from the screen and nobody would get anything from that. So, 4 of the main manufacturers are Allen Bradley, Siemens, Omron and Mitsubishi. Now, the most common that you'll probably find in the industry is the Siemens and the Allen Bradley. The Omron and the Mitsubishi tend to be a little bit more obscure in my experience, but again, if you guys work with just Mitsubishi or Omron, then I apologise. One of the 3 types of PLC is the small, sometimes called the nano PLC. And what this is it's an all-in-one unit which is essentially built just to be placed next to a bit of machinery that's working. They usually got rubberized feet. They sit on top of the machine. They have a very set amount of inputs and outputs. You can't put expansion cards on. You program them using the actual interface on the screen, so they're quite limited in what they can do, and they're only for small scale operations. So they're not expandable. They're relatively easy to program, but it's again sold them via the screen and sometimes SD cards. But yeah, it's a little bit difficult to reproduce the software. If you've got 50 of these to program, there's 50 you've got to program from the screen. And like I say, they are set. So if anything breaks inside the screen, stops working, there's very little you can do. You just replace the whole unit. So just a quick overview. They are a full PLC in one box. They've got all the memory, the CPU, the inputs and outputs, any interfaces that you've got in there. And if you're lucky enough to get one with some comms, then all that will be in the box as well. They're non-expandable. The inputs and outputs that you start with are what you have for the life of the PLC, and that means that there's no way to upgrade the I/O. There's no way to upgrade the inputs and outputs at all. There is as well a limited number of applications that these things can work from, which means that essentially they're set for basic PLC applications. Turn lights on and off, reading one sensor and maybe setting off one actuator. Or they could form part of a bigger distributed control system, but it's unlikely with the smaller ones. Like I say, they are programmed with a small display, which makes them a little bit harder to program. They're simple enough to program, but the actual reproduction of that is a little bit more difficult because you've got to go from machine to machine. They are attached directly to the machine. A good example of this would be to run the direction or the speed of a conveyor, maybe a simple process machine, putting lids on and off, or detecting when bottles are full or something like that. Or even a pneumatic station, just moving a simple arm to move, boxes out the way or something. The next one we're going to look at is the medium, sometimes called the micro or compact modular. Sorry. These ones come where the CPU and the memory and stuff tend to be in the main box, and then you build up any periphery that you want, from expansion cards. So these do tend to, you can upgrade them. I'll just quickly run through the ups and downs of this. So basically, the main box comes with the PSU, the CPU. You tend to get the input and output and the comms stuff in there. If there's anything in that box that you want that isn't there, or if there's anything that you later want to upgrade to, you can expand that. It's not really a problem. It is fully expandable. They can be fixed to a DIN rail, which means that they can be mounted inside of a wall mount box, and they can be networked. Means they can be networked quite safely. nothing's going to get knocked out, and none of the comms cables are going to get damaged. Um, good example of this is where they used to control small automated plants. So all the way from bringing a jar in, filling the jar, capping the jar, and pushing it out to a packaging section, or even part of a large distributed control system. There's two examples of this. The first one is individual control, where literally the PLC runs absolutely everything. So you've got the PLC in the middle there with an operational interface. The PLC turns the motor, which turns the lead screw, which feeds in a certain amount of material. The sensor reads the material as coming up flush with its little sensor there. It feeds that back to the PLC. The PLC turns the motor off. The cutter then comes down and cuts off the end. The opto module confirms that's been done, and once that's been done, the motor's then turned in, it moves the stock on and brings new stock in, and away it goes, and it just repeats. Another version of this is centralized control, where it's part of a distributed control system, a larger system. So the PLC might be responsible for scanning packages and either moving them onto one conveyor belt or the other, depending on weight, height, destination, things like that. So a distributed control system, the medium PLCs that we're talking about tend to make up the individual modules that control certain machines. And what you would do is you take a larger PLC or a modular PLC, and that would replace the host computer. Nowadays we wouldn't use a computer for this. We would use a larger module PLC, which we'll come on to next. This is sort of like late 90s, early 2000s tech on this picture. If you look closely, they've actually got serial ports on these PLCs, just as a sort of a throwback to the edge. So yes, this wouldn't be done by a computer anymore. This will be done by a larger distributed control system. And then to make it simpler, to make the human interface simpler, we'll have some sort of human interface device, usually a touchscreen nowadays, although it shows switches and knobs and things there. Nowadays it would normally be a touchscreen, which would then control what each PLC would take inputs from the human and control what each PLC was going to do. Which brings us on to the large rack-mounted ones. Now, these PLCs tend to be completely modular, so you buy the CPU separate from the you source the CPU separate from the memory, separate from the inputs and separate from the outputs. The comms systems, the comms cards, any specialist input and output that you need are all sourced completely separately. So the modules stand alone on cards or slots that go into a rack or a backplane. These then go into, sorry, I must apologise, I've got my little 5-year-old off school at the moment, he's making lots of noise. Modules are placed onto rack-mount systems, so they can be placed near the machines, but normally these things are sort of a supervisor, so they'll act as a master to maybe another slave PLC. So these things, although it can be mounted pretty much anywhere, they tend to be more of a control system inside. Like I say, they're usually housed in a cabinet for safety. One, to stop people from touching live terminals, because quite often your power supply is wired inside of the cabinet for this one, so there is a risk that people could meet live electricity at mains. But another thing as well is it's to keep prying hands out. So if you've got technicians that are wanting to get involved and see what's going on and pressing buttons and things, if you've got locked in a cabinet, there's less likelihood that's going to cause any damage. They're very, very flexible. You can add whatever you want to them. You can buy cards that do pretty much anything for the larger ones, because everything's modular. So if you wanted to upgrade your Ethernet communications card to a Wi-Fi one, you just slot out and slot back in again. You don't have to necessarily upgrade anything else, unless, of course, your other kit's outdated and it's not compatible. But generally they all work together. Like we say, it's expandable, so if you decide that you want to change the operation or the tooling of a machine, you just buy extra cards or different cards, slot them in, slot them out, reconfigure as needed. And typically they control other PLCs doing a process, so these things would control medium PLCs doing semi-complicated things. So if you had a medium PLC controlling a production line, taking, I don't know, like I said before, glass jars coming in, your medium PLC, measures the amount of glass jars coming in, makes sure they're in the right place, fills them to a certain height or a certain weight, puts the cap on them, moves them on. The larger PLC will then say, well, we've moved 10 of these jars on, activate the next stage, which will then be sterilising and putting labels on and things. So it's like a supervisor over the other PLCs. It can work in master and slave, depending on the topology. So you could have a whole sort of line of slave PLCs underneath that are hypervising the processes going on. Generally, that's not really necessary nowadays with the introduction of Arduino, professional Arduinos, and things like that run inside of the rack-mounted units with these. So usually you just see a master connected to loads of medium PLCs. But again, if you're looking at legacy stuff, if you're going into a factory that has PLCs that are 10, 15 years old, you just never know what you're going to see. So typical specifications for these things. I'm going to run through these fairly quickly, so you might want to pause or go back and re-listen to this. So we're going to look at memory type and size, how memory's read in, the sizes of memory, the configurations of that, processor speeds, what's meant by speed, the 3 different ways that we measure the speed of processors, inputs and outputs, and expansion. We'll also look at specialist inputs and outputs. Is there anything sort of unusual that you connect to? Normally we use the 4 to 20 milliamp connections for PLCs, the standard 4 to 20 milliamp connection system. However, you can get specialist ones that interface with CMOS up to 15 volts and things like that. And obviously comms, networking, and the initial sort of setup cost, maintenance cost, and running. So when we're looking at memory, there is really 3 different types that you want to look at. There's RAM, ROM, and EEPROM. RAM is random access memory, so you can read from them, write to them at certain addresses, and essentially use it a little bit like a USB storage drive or a hard drive. You can write to them, take information from them, store stuff in them. ROM is read-only memory, so you can only read from it. It's a little bit like putting a CD into a CD player. You can only read the music back unless you've got specialist hardware and software. You can't write to that CD. And EEPROM is electronically programmable read-only memory. So what you do is you can reprogram the whole EEPROM by flashing it and then putting a whole new program on there. You can rewrite to these, but once you've rewritten the program, which is quite an extensive thing to do, you can then only read from it until the time comes to refresh the whole program again. So RAM tends to be what we call volatile, which means that when you turn the computer or the PLC off, whatever's in the RAM tends to disappear. Although nowadays you can get battery backups for these, which make it a little bit similar, especially with sort of the advent of lithium-ion batteries, which last for a very long time, no memory effect. So we do have systems to keep this in place. But also as well, ROM tend to be non-volatile, so you can turn off and on, and the information tends to stay there. Another thing with RAM is nowadays we tend to get things like SD cards and stuff that you can put into the PLCs, which is RAM, but it isn't volatile, so it doesn't necessarily turn off when lose the data when you turn the PLC off. So if you turn your phone off, you don't lose the data stored in the memory inside of your phone necessarily. It's a little bit like that. So legacy stuff, RAM definitely volatile. Newer stuff, RAM not necessarily volatile. So I'll leave that on the screen for just a couple of seconds if you want to take a quick picture of that, although you will get a copy of this PowerPoint on Moodle, and there'll be a link in the description below. So memory sizes, we tend to look at them in kilobits or just bits. There's bits and bytes. That's a whole different lesson for a whole different day. We can read and write words, which is 16-bit registers. They tend to be for things like data logging and things like that. The size of the registers and the memory that you use depends on the type of inputs and outputs that you've got. So if you've got 100 inputs and outputs, for instance, loads of cards, you'll want a 16 or a 32-bit registration system. The size of the program that you're going to load onto here as well. So if you've got one medium PLC run the whole rig, you're going to need a fair bit of memory there. And any supervisory functions. So is there any sort of error control? Is there any PID systems in place where they're constantly reading, writing, recording, and any future expansion? So if you think that you might be upgrading your program every 6 months, then obviously you're going to buy a a slightly larger memory to accommodate the upgrade in size. Processor speeds, so they're measured in how many operations we can do per second. You probably know this from regular PCs. Your processor is measured in hertz, which is cycles per second. But this can be, a cycle can be a bit operation, which is just one of zero, a word operation, which can be a string of data, or special instructions, which can come down. It can be arithmetic. There can be data. You can do and or not, NAND, NOR, things like that with the PLCs. The inputs and outputs, generally the working voltage is 24 volts, which is usually standard. You can get buck boost converters to make them compatible with other technologies such as TTL and CMOS. You can either sync to an input, or you can source an input using either NPN or PNP technology. That's, again, you can Google that dead easy, PNP, NPN, and you'll see exactly what I mean by that. It's whether the current flows into the sensor or flows through the sensor. Any specialist equipment, high-speed encoders, any analog stuff, like I say, the 4 to 20 milliamp stuff, mainly done for passive temperature and pressure and stuff, they can be purchased pretty easily. Again, it's all about the ecosystem around, so if you've got a fairly rich ecosystem of PLC parts, it's fairly easy to get a hold of replacements and stuff. But if you've got a specialist part that's made just for your PLC and it's only available from Malaysia, things like COVID-19 and political turmoil can cause issues. So, it is all about, if you're going to put specialist stuff on, make sure that you've got the ecosystem around you to support that. We do tend to have fairly high-speed switching on more modern PLCs. Don't forget, these are relays that we're switching, but quite often they tend to be solid-state nowadays, which can be quite high frequency. So you can do things like PWM, pulse width modulation, to speed control motors or dim LED lights and things like that. You can also do PID control, so you can do position control, temperature control very, very accurately. PID does require several sensors to read in to look at how much work's been done, how much work is being done at the moment, the rate of change, the integration under the curve and things. So that is definitely something to research. PID controllers for PLCs. Now, communication networks, depending on what you want. Do you want a system that you can just plug and play? So are you going to, be taking this thing out in the field and sticking a wireless card in it? Are you going to want it just on the shop floor and just ran through Ethernet for 20 years? How fast do you need it? Bits per second? Are you going to go to the maximum of your network, or are you going to leave some room for future expansion? Which topology are you going to use? Master, slave, peer-to-peer? Again, depends on the setup that you've already got there. Quite often, you'll be using legacy networks already set up, because the network's one of the most expensive parts, because you've got to drill through walls and go through ceilings and things. So if you've got existing legacy networks already there, chances are, if you're upgrading PLCs, you're going to be using that, unless you're using wireless communication, obviously. And there's some further information at RJ45, CAT and USB cables and things, which does come into, I think it's question 5 or 6 on assignment 1. So yeah, there's some more information there for you, which I'll leave on this slide for you to have a little look at. Again, it's answers towards one of the assessment questions. I don't want to give too much away there. If there's anything else to consider, I would think that sort of what voltages you're going to be working with is very important. Power supplies, input and output voltages, and any expandable I/O. So anything that's specialist, that doesn't necessarily use the analog 4 to 20 milliamp setup, or doesn't use the standard digital 5 volt TTL setup, or even CMOS 15 volts. Is there anything specialist or unique or antique that you're using to read in and out? That's got to be considered. What we'll do for the next slide is we'll look at typical configurations. Typical specifications. So we'll look at specific cases of Omron PLCs, but we'll leave that where it is for now, because we're getting on for 20 minutes there. I will link this slide below to Moodle. It will be on Moodle, so you can take the full set of slides for yourself. And if you could just keep an eye out on your emails for any future updates, and please like and subscribe so you get a notification when new videos are posted. Thank you.